So we're getting our E rules today for derivatives and such. Well, first of all, this is not a derivative problem right here. This is just a solve. This is an algebra problem, kicking back to old stuff, but there's a reason, because it's going to come into play here and there. All right, so if we were going to solve something like this, first thing I would do is I would rewrite it, or as in a log form. I'm going to rewrite it like this, because I'm used to looking at it like this. When, you know, in log form you go here to here to here, so I'm going to look at it like this so it doesn't confuse my eyes. If I rewrote this as a log, is it going to be an log or an ln? Ln, because it's got the e in it. That's how we know. So I'm going to rewrite this as ln, and you know it's base e, but you don't have to show it right there. It's up to you. Of what? 7 equals x plus 1, because you always go here to here to here. Wait, when you put it down.
Don't we have to say there's a base? Or no?
It's an E, and you know it's there, so you don't have to say it, or you could
No,
say
I mean
it.
from the first one.
Yes. Oh,
There
wait.
is no base from the first one, right? Because there's no log.
But as far as the exponent, it's base E exponent x plus 1, if you want to think about it like that. Okay, now let's pretend we're going to solve for x here. Solve for x. What would you do?
Subtract 1.
Subtract 1. So x would equal ln of 7 minus 1. I put parentheses around 7 simply so you don't think it's ln of 7 minus 1. It's only ln of 7, then minus 1. This is how, that's as far as we can go without a calculator. It's solved, okay? So that's why a lot of your stuff y'all get with solving, like you got to find your critical numbers and stuff. This is why we're remembering this. Okay? All right. So let's look at these properties then. Here's one property. Now, you don't have that?
The next one's another example.
Oh, is it? Well, scribble it in. I don't know why y'all ain't got the property, but I want to show you here why this is true. Why the ln e to the x is x. If we rewrote this as a exponent, if we did our little thing here, how would it read?
E to the x equals x.
Equals e to the x. Look at it. E to the x equals e to the x.
Wait.
Or excuse me, did I
E
say
to the
that
x.
wrong?
E to the x. Yeah, there's a base e.
There, yes.
To the-
excuse me.
To the
excuse
x
me.
equals x. Because you use the exponent.
E to the x equals
All of them.
e to the all of it.
I thought it was just the exponent.
No, we use the whole thing.
Well, then would it,
Have we been doing that?
Yeah. Hang on.
was it on the same on the last one?
Person
We did
hasn't
that.
been doing that.
Now see, look, we're going different here. This is E going to ln. Here's ln going to E. Yeah. Huh?
Yeah.
Yeah. That's why it looks weird, I think.
It's confusing because there's two E's.
Yes, it is. It is. You can look back, but I think we're good. But it's just look the way it looks. You can see why this property is true then, because this is true. So my point is, if you're working a problem and you're ever sitting on this, you know it equals this. If it helps, it might not. All right, let's rewrite this one. Let's put this. Look, this is an exponent form. Yeah, it's got an L in it, but it is an exponent form. So if we rewrite this one, ln understood base e
Yep.
of what?
X.
Equals,
L of X.
yes. Now this is duh to duh. There.
Are the x's exponents?
So it'd just be.
L and e to the x? Is that?
Wait. The
It's the same thing.
this
Yeah, is that one? Is that x on there an exponent?
no.
Okay.
No. This ln of x technically was the x. But these are the same.
Yeah, I was about to say they equal.
They equal the same. So these are two properties. I wouldn't memorize them, but if you ever were working a problem and you got to that, it could help you out. All right. So let's okay. Look, still algebra for us right here. We're just solving. Okay. So if we're using a property here by rewriting, let's rewrite it. E to the fifth equals E to the fifth equals 2x minus 3. You just gotta be careful. Alright, so if we're solving, you do what? So you got E to the fifth plus 3 equals 2x, and then yes. So you just solve your normal little way. And that's as much as we could get.
I like it.
Alright. Again, the reason I'm telling you this is because y'all get into the critical numbers and stuff where you gotta solve and then you get stuck, so just practicing that. Now we're gonna get on to derivative. Alright. What's your next one look like then? Okay. Alright. I don't know why I was missing a page, and I feel like I'm missing a page here too, but I'm fixing to tell you what the rule is. I never said it for some reason. Whatever. Alright, so here's your rule. I'm gonna squeeze it in. I don't know why I'm missing this.
It's kind of a big thing.
It is, kinda. Derivative of e to the x is e to the x.
It's the same thing.
It's itself. Derivative of e to the x is e to the x. Alright? But that's assuming it's just e to the x, and a lot of times it's not. It might be e to the 4x, you know. So let me give you the general rule for this. So derivative of e to the u, and I probably shouldn't say u there, but anyway. U being any exponent, could be 4x, could be x squared plus 1, whatever. It's itself times derivative of exponent. The general rule is itself times derivative of the exponent.
Okay.
E to the x rule is really pretty easy. It's easier than learning the basics of logs. Really.
Wait. Say that again.
Derivative of e to the anything is itself times derivative of the exponent. That even applies here. Look at it. E to the x times 1. That's why.
So that first one would be 2x minus 1.
Okay?
Multiply that times 2.
Exactly. So as he just said, this would be itself times derivative of the exponent, which is 2. So,
2e.
yeah, that would be how they would rewrite it.
Alright, I like it.
Yeah, I like ease.
Now they're my friend.
Yeah,
Let's not-
the e's are.
Let's be honest.
Alright, but we're still practicing. Alright, so this would be itself times
Let's do quotient.
quotient, alright? So times quotient rule of this. So that would be
Low, high.
low
From 0.
0 minus high times 1 over so this will be
3 over x.
so this is gone. That'd be positive 3 over x squared.
Yes.
So I'm just gonna write it 3 over x squared times e to the
Is it okay if you put the E on top of
yeah, that's okay. I just didn't think about it when I wrote it. Yeah, E
it?
is in line with the 3.
Do we have to move it down because there's a negative in the exponent?
I don't think, let me
Bless you.
look.
Thank you.
I don't think they worry about that so much. I don't think so. We'll watch for it. Ma'am?
What do you Because there's a negative in front of it?
Yes, it is. There. There. But that's still. This is positive 3 here.
This ain't bad.
And then it gets,
Yeah.
So with these, like, say I'm going from this one to this one, I do. That E is the same, right?
No, the understood little e would be that e.
Okay,
So that would be,
and that is,
yes, yes. I know. All right, let's try a relative extrema. Because really, they might give you an easy derivative like for multiple choice, but then they're gonna mix them in. All right, relative extrema, guys, you with me? All right, derivative, f prime, how are we getting it? Product rule. First times derivative second is
E to the x times 1.
times 1, yeah. All right, plus second
1.
times 1. All right.
wait. Oh.
First derivative second plus second derivative first. That works nice, that gave us an e to the x. So, let's see. So really, we've got x times e to the x plus e to the x. All right. So we're going to set that equal to 0 because we're going towards relative extrema. All right. So this equal to 0.
What are we trying to get back to?
We want to solve for x. Now,
Yeah,
Do-
can you
what-
not take out the x?
we can take out
An E.
e to the x. Take out an e to the x. All right, because they both have it. So that would leave you what?
X plus 1.
Now, here's the beauty of this.
creates that.
If you break it up into factors, then you can set each factor equal to 0. You know how that works.
Yeah.
If it's factored, you can set each factor. You don't have to worry about it as a
Can you not just
whole.
divide by e to the x and it just
That's what
cancels
we
out?
were
You
saying.
you will, but it loses it loses a number is the problem. Remember on last year sines and cosines, and if you were solving those equations, if you multiplied and something canceled, you'd lose a possible solution. Same kind of idea here. So we kind of need to know about this x plus 1.
So it would be x equals -1. is that
Okay,
it?
so this will be, so there's a critical number, and then
E to the 0
rewrite this.
So
ln e
to the 0
equals
0 equals X.
or yeah.
ln e 0. I don't think that can happen. Ln of 0 on a calculator gives you an error.
So
Here's why. Because think about, even not rewriting it, think about it. Anything, e to the something's never going to equal 0. Even e to the 0 equals 1.
so
It can't happen. So this goes nowhere to us. This is our critical number. That's not a D&E.
it's not.
That's not a D&E. It's a, we can't solve from here. It's a, we can't get an X is what it is.
Okay.
So, but yeah, good question though. All right, so then we're testing around
-1.
just -1. All right, so we're gonna test
-2, 0.
0,
Take.
-2. Okay, so f prime of -2, we're plugging into the derivative. We're plugging into that e to the x times x plus 1. It's probably easier to look at it. So e to the -2 times -2 plus 1. We're plugging into the derivative. It was e to the x times x plus 1. I'm plugging in -2.
Negative e to the negative.
So
Oh, okay.
technically, wouldn't it be if I fix this?
It'd be negative.
It'd be negative then.
So it'd be negative that
Yeah.
which in turns equals negative 0.1353.
Okay, if you didn't have a calculator, we know that E is about 2.7 positive, so we've got a negative answer here, is all we care about. All right, so let's see, F prime of 0, oops,
Wait, wouldn't it be, would the negative be, oh, never mind.
No.
I got confused.
all right, that's okay.
It'd be
E to the 0 and then 0 plus 1. So E to the 0 is 1, so positive 1, or just positive. Okay, so we have a what? A relative minimum at, and let's find the whole order pair just because, at -1 comma, and we're gonna have to go find it because I want you to know how to do that, especially with these E's. So where do we plug in to find that? Original. So we're gonna plug -1 in, way back up. We're gonna plug -1 into this. So it would be -1 times E to the -1, which equals,
-1 over.
negative 1 over E.
look at it. E bumps down, becomes positive, so it'd be -1 over E. Alright, so that's our Y value. That's it. I just want you to know how to deal with these E's. Alright, so this is Y value, -1 over E. Because, I'm going to go ahead and do it right here, because,
F
Prime of X
negative.
changes.
yes. If you did this, they'd give you bonus points probably. They'd be so excited because you know how to plug in, get your E's, you know how to give Y. You'd be wonderful. You'd be wonderful.
And now.
All right, and we will stop right here, children. Thank you, Hayden, if you'll, thank you.